Hello everyone. Thank you very much for joining one more session of the GenAI from Idea to Reality series of events that is organized from the Data Zen Greece community. This is the second event that we're organizing in this series of events, during which we will try to build a GenAI focus in our community, to share knowledge between us, to introduce practical innovations, practical applications of this innovative idea for several industries. We will try to develop community skills and personal skills, obviously, and to encourage innovation amongst us. So what we will like to ask you to do is, if you enjoy this kind of events and you'd like to participate in any way as a speaker, as a contributor, please join the Data Zen community Greece, and let's connect and produce some more events like this one. Without further ado, let's jump into the session for today. So what we will be discussing in today's session, that we're going to be focusing on applications in hospitality, tourism, and recreation. You can see the agenda on the right-hand side. So we will be focusing on GenAI in travel and hospitality. We'll have a very interesting live chatbot demonstration. Also, we're going to be discussing how to customize LLM models. Some input regarding how to use external tools within this integration of this architectural insight that will be covered also. And then we will move to a Q&A session with any questions that you might have. So let me introduce the two speakers for today. We have Attila and Konstantinos. So Attila is a data solution architect in EPAM Systems. He's based in Budapest, Hungary. He has been designing and implementing data-intensive solutions for more than 20 years. He has a rather extensive cloud experience. Is a AWS certified professional architect and is focusing on GenAI and vector database. We also have with us Konstantinos, who is also a data solution architect for EPAM Systems. He's based in Athens, and he has more than 10 years of experience in data engineering, BI, and data architecture. So Attila, Konstantinos, the floor is yours.
Yeah, thank you, Apostole, for the introduction. So let's start with a quick introductory slide regarding large language models. Large language models have captured significant, let's say, attention due to their remarkable ability to generate human-like responses. But of course, this technology is not something new in our world. Their predecessor, Audrey, released at 1950s. It was a speech recognition technology that could understand all the 10 digits. Then in 1990s, we have the known to all of us T9 technology for mobile phones. But eventually the real breakthrough happened in 2017 with GPT technology. And after that, we have several releases in this technology until 2023 with GPT-4. And these large language models and these nice, let's say, human-like text responses have gained the attention, and more businesses try to understand how they can utilize them in their applications, in their business activities. Some of the usual applications of LLMs are using them for user interface and chatbots, use them for integration activities in existing platform and products, using them for recommendations, for code generation optimization. They are perfectly good for content generation activities, but also they can be used for data analysis. And we are going to show one application of this technology with the help of our presenter today, Attila.
Hi, everyone. Thank you for inviting me to this series of sessions. It's great to be here. So today I would like to share with you our experience while designing and building a solution based on generative AI for one of our customers. Unfortunately, I cannot name the customer, but they are a very large player in the travel industry. and they have a lot of websites related to this industry. They have different membership clubs. They offer special discounts to their customers, and they cover most of the different areas of this industry. Like you can book hotels and maybe resort deals through them. You can rent a car. You can book flights. They also manage, or they also publish some offline magazines, travel magazines. You can you can book different activities while you are on holiday. So as I mentioned, they are a very large player, and they wanted to give GenAI a try. So together we found out one possible use case. And the main idea was to develop a virtual travel agent, which behaves pretty much like a human travel agent would do. So you could, for example, if you have a human travel agent, you can walk into their office and start discussing. You can go in with a special plan in mind, like, for example, you might know exactly where you want to travel and you just want to get some uh, good deals. But it can also happen that you don't exactly know what you are looking for and you are looking for inspiration and recommendations. So this chatbot that we developed is suitable for both of these use cases. And we actually see an example for both.
Attila, one question from my side here. Uh, Could you please maybe mention some of the problems that the client was trying to resolve by building this application, by
Mhm.
doing this initiative? In my mind comes, for example, yeah, I don't know, big waiting queues in their offices, or maybe to reduce the cost of this activity, or
Mhm.
maybe some benefits that they expect, like enhanced user experience. Could you please name some of them that the client was trying to resolve?
Mhm. Absolutely. So I wouldn't say that they had any special problem, but they realized that Gen AI is here with us and it kind of reforms every industry, and the travel industry is no exception from that. And this might be a new technology right now, but in a few years it will be mainstream. Every company will use it, and it's very important to gain experience as soon as possible in this domain. The second is to also see how their customers react to such solutions. So one of the things that we are trying to do is to understand how the end users react to this, whether they like it, what are the features that they like, what things are working, what things are not.
Mhm.
So the main driver was to gain experience and test the industry's reaction. But of course, if we are developing something, we are also looking for return on investment. So we hope that with this solution, we can attract, for example, tech-savvy new generation of customers. And we also aim for cross-selling products. Like, for example, if we have a customer who is booking a hotel with us, with this technology, we might be able to offer them other services that we provide that they might not be aware of.
Mhm. So yeah, increase the users list, subscribers list, and the biggest revenue per user, right? Nice.
Exactly, yes.
Mhm.
Mhm.
Nice.
And with that, let's jump into the demo. So I prepared kind of two short demos for these two different customer journeys. So the first one will be a customer who knows exactly what he wants. They want to travel to Paris and book the relevant services. And the second use case will be more an exploratory one. We have a customer who just wants to go to a beach vacation but has no specific destinations in mind. Let me try to switch to my demo. I will start a new conversation. Okay, so this is our user interface right now. So it's pretty simple. On the left-hand side, you see a typical chat interface with a message on the top and the text box in the bottom where the user could type in their question. but we also wanted to help the user kind of to spare some keyboard clicks, and we offer canned responses for the most typical things. So uh, below the text box, we always display potential text that the user might want to type in, and it's enough to just click on that. So for example, right now I could click on, I have a specific destination in mind, and this is kind of identical with typing in this sentence. So I can mention that I said that we know that we want to go to Paris, so it's enough to type in the destination name, but of course I could also write a complete sentence like I'm interested in a Paris vacation. We instructed the Gen AI to reply in a positive tone and to list immediately potential insights, kind of to inspire the user. So this is why it immediately started to list me the potential things to see in Paris. And then it asked me about the dates. So let's assume that I know exactly when I want to travel. It should be in the beginning of September. Let's say between September 1st and the 6th. It's important to note that I can be quite fuzzy with my text. So even if I don't type in full month names, or even if I mistype something, the large language model and GenAI will usually understand what I mean. Um, so it will ask me how many people will be traveling. Again, we kind of identify that it asks about the number of people, so we displayed a couple of canned responses. So it's enough to click, let's say if I want to travel with my wife, then I can just click 2 people. And it confirms my selection. And ideally, I should see some hotel recommendations right away. And indeed, I see some hotel cards. Now, we render these hotel cards to be familiar to the end user. So on the customer's web page, they see the customers usually see the quite similar hotel cards. And we also display links to other services, like to fly. I can also book a flight, or I can also rent a car during this. Let's see, I can browse these hotel cards, and I can see that we have different hotels with different star ratings. Let's say that I'm interested in only higher end hotels. I'm not interested in 2-star hotels, so I can also type in 3 stars and above. And the application will understand this and will filter down the hotel recommendation to this. And as you see, I can see only higher rated hotels. Okay, let's see that I also have a plan to learn more about the French cuisine. So I want to go to a cooking class. So I can also type in cooking class while I'm in Paris.
Until actually this maybe covers one question I had. So one question was why this GenAI solution is better than a classic chatbot, but you already have proven here, right, that you can answer even for cuisine, and it can you can ask even for cuisine and get answers, proper answers by the GenAI, right? Any other
Exactly.
benefits, yeah,
Yeah.
that you consider?
So I feel that traditional chatbots are good for up to an extent, but they usually have a very strict workflow. So they have to be programmed in advance, and we have to basically know in advance what questions our end users will ask.
Mm-hmm.
And I'm usually, I will usually become quite frustrated when I'm using standard chatbots because they are prepared for a couple
Yeah,
of known questions. And if you ask something else, they will not be able to help you. And sometimes you end up in running in circles and you cannot get an answer to
yeah,
your question.
yeah.
Chatbots based on Gen AI are much more open. So you can ask any question basically. I could mention that maybe there is another challenge with these kind of chatbots is that they are too chatty and they can answer anything really. So a user could start interacting about things that are unrelated to travel. For example, they could start to talk about football or anything else. And we, of course, don't want that. So with these chatbots, it's like uh, it's kind of the contrary of this challenge. We kind of need to restrict the chatbot and teach what is the domain of our business, and then it should keep the answers within that domain.
Mm-hmm. Mm-hmm. Nice. And yeah, I see that you just write two words and it can understand perfectly and answer really, really well structured, right? I guess this is a good, very good capability of the Gen AI, but also there is a way for you to configure that, right?
Yes,
How?
uh, exactly. I will talk a little bit more about that in the following slides, but the main
Okay.
idea is that we can send instructions to this large language model on how to behave, and it will follow it quite nicely.
Mm-hmm. Mm-hmm. Nice.
Okay, let's switch to the other use case because I think we have limited time. So I will start a new conversation, and now let's assume that I am the customer who doesn't exactly know what they want. So I like, for example, this image here with a seaside, and I'm thinking that it would be great to go to a beach vacation. So I selected that image, and it starts recommending me a couple of places. And on the right-hand side, we display kind of matching images. So I can also browse those images to get some insight. Um, let's imagine that I see here Santorini, Greece, and I heard good things about Greece. So let's select that destination.
We will need some vacations after this demo, Attila.
Exactly. I think that's part of this demo, right? Okay, we get some nice photos about Greece and Santorini, and it will ask me when I want to travel. But before that, maybe I change my mind and I think that, okay, Santorini might be quite crowded. Let's try something where there are, which is less touristy. So it offers me a couple of other options. Let's select one of them. Okay, volcanic landscape sounds great. Let's see what's in Milos Island.
Pretty good. I mean, these islands, okay, some of them are pretty known, but some other are pretty, you need to have experience to suggest them.
Hmm. Hmm. Cool. So stunning beaches, unique volcanic rock formations, hiking. Okay, that's great. Sounds good. I like it. So I want to go there. It again asked me about the dates, and we kind of offer typical holiday dates. You see Thanksgiving, so this is more prepared for American customers. But let's say I don't know when to travel, so I could even ask the LLM to recommend me something.
Yeah, maybe some months that are not so, touristic.
Exactly,
Yeah.
exactly. So let's see what it will recommend. So yes, it depends on preferences. May, June, September, October are considered shorter sessions. Crowds are smaller. Okay, let's say that I want that. So September sounds good to me. So let's make it, let's say 10 to 6, or maybe let's say make it a bit longer. That's 8. It's a fantastic time. That's great. I get some insights. Temperatures are given in both metric system and American Fahrenheit. Great. How many people will travel? I can actually be quite fuzzy with my answer, so I can say that me and my wife will travel, and it will still understand that this is two people. And again, it shows, displays me what to do. I mean, what to see while I'm there. And again, I get some hotel recommendations, which is great. I can click any of those to book a hotel. Um, let's. I see this build itinerary. Let's try to build an itinerary, kind of a plan what to do during my stay, and it will
Like a
come
proper agent, right?
exactly. So from my dates, it will know that this is a 7 days vacation. So it will use that information to display the recommendation, which is great. And let's see, to eat, maybe to see on every day where I can eat. Maybe I will get some good restaurant recommendations. And indeed, it gives me some uh, restaurant recommendation for every day. And I can continue discussing with it. For example, I can even ask it, and uh,
So again, it is proven that with this solution, there are unlimited flows for the end user that can follow, something that
exactly,
overpowers the classic chatbots, right?
exactly. And the good thing is that we don't need to program these workflows. It will come automatically from this large language model.
Scalability is there already, yeah.
Yeah.
It knows also
Okay.
GameStar. Great. Uh, Attila, could this work with a different language maybe, or it needs
Uh,
some different configuration?
it should work. I tried it with Hungarian language and it works. If you can send me a Greek sentence, we can try it out.
Yeah,
Um, of course, as these language models were trained from the all available information on the internet, where English is the most widespread, then they are usually better in English, but they understand other languages quite well without actually any additional programming. So yeah, I received a sentence from you. So
yeah.
let me try to paste it in.
It means suggest me Greek food, Greek dishes.
And I don't understand, of course, this, but you can tell me how accurate it is.
Hmm. It replies that, yeah, fortunately it cannot understand instructions in Greek, but eventually it replies that there are some specific dishes, yeah, the same result in Greek, actually.
Okay, great. Mhm.
Okay, so even it could work for Greek users or Hungarian users without any limitation in the language, right?
Exactly.
Hmm. Super.
Okay, so that was it from the demo. Let's switch back to the presentation. And in the following couple of slides, I plan to talk to you about kind of the technical challenges that we had and some interesting stories on how we implemented the application. And kind of the main interesting area of these Gen AI based solutions is how to combine different data sources and how to integrate all this knowledge. So on one hand, we have the public knowledge of the large language models that we just seen. So when you start a conversation, for example, with ChatGPT, you see that it knows a lot of things, and yeah, that's great. But in most cases, we also have some private data. I mean, companies have some private data, and we want to show those too. For example, I will also talk to you how we extract the destination recommendations from the LLM to display them as a predefined responses. But I will also show you how we integrate the hotel information that the company has with this chatbot. And I will also talk about how we kind of integrated with these images on the right-hand side. So let's start with the large language models. So a large language model, based on the definition, is basically a piece of software that is designed to understand and generate human-like language. So the main key points here is that they understand the human language and they can also generate human language. So this is how we can interact with them. And we can create such a language model by training on a vast amount of text data. So we need a lot of data to train such a model. And when I talk to people about this solution, they quite frequently ask me how we trained our model so that they can interact as a travel agent. And the good news is that there are a couple of customization techniques, but in most cases, we don't actually need to train a model. So the available public large language models are generic enough to be able to be used on any kind of domain. So you will only need to train a model if you have some completely new domain for which there is no information available. Like for example, you invent a new language and you want your chatbot to interact in that language, then you would want to train a model. And of course, training a model is quite expensive. You need a lot of data, you need a lot of computers, and it takes time. So the good news is that we don't need to do that. There is also a technique for fine-tuning a model, so to take an existing model and fine-tune it, but that's again not relevant, and we don't need to do that for a typical chatbot. There are basically two techniques that we will need to use. One of them is prompt engineering. This is about sending simple text instructions to the large language model where we can instruct it how to behave. We can tell it that you are a travel agent and your goal is to help the customer in finding their vacation, and they will start interacting in that way. I will show some examples for that. The other technique is retrieval augmented generation, or RAG in short. That's a technique for combining your private data with the public knowledge of the LLM. So basically, this is a combination of an intelligent search solution with a GenAI. And when the user types in something, we can use this search engine to find the relevant documents in our own document store, and then give it to the LLM to use it and formulate an answer. Another interesting question is how we can get such a large language model and how we can host it. So there are basically two major ways to use a large language model. One of them is to download one from somewhere. So there are a lot of companies who are developing large language models for different purposes. I just included here a link, this Hugging Face /models, where you will see that there are more than 700,000 different models for different use cases. So you can search between them and download any of them. Of course, if you use such a model, you will need to host it somewhere and you will need to manage that infrastructure. This is kind of a complicated thing, but of course you can do that. But most of our customers go for a cloud solution, and all major cloud providers actually have a solution for a large language model as a service. So if you go into this direction, you don't need to bother with hosting your model. You will be able to always use the latest models, and you will basically pay a couple of cents for every thousands of requests. And we also went into this direction. So our solution is on AWS, on Amazon Cloud, and we are using Anthropic Cloud. This is one of the mainstream models available. It's not ChatGPT, but it's as performant as ChatGPT. And we are basically paying on a request basis. we did some calculation, and an average chat session. So a chat session is a discussion that we just performed during the demo. We actually performed two different chat sessions, so that will cost about 15 cents. So it's basically negligible for most of the companies. But of course, if you make a chat application which will have hundreds of thousands of users, you of course have to factor that in, because this can of course be a lot.
Attila, one other question that comes in my mind from this slide. Okay, Gen AI, perfect. They don't even have to be trained. The knowledge is there. You can just go find it in a already, let's say, configured service and just integrate it with your use case. But okay, there is a lot of discussion regarding personal data and how these models, this technology manage personal data. Let's assume that in your previous demo, you were going, for some reason, for any reason, I don't know, passing the chatbot any of your personal data, like your ID or any card, payment card number. Uh, where are these data stored in
Mhm.
the solution that you implemented, and which is the suggested approach to manage these cases?
Right, right. This is a very good question, actually, and many people are kind of hesitating about these problems, about using public services. And the cloud providers and the providers of these language models also understood that this is kind of a concern of their end users. So basically, in their terms and conditions, they promise us that they will not use the data that you type in for training their models. But of course, we cannot be sure about that. So we can believe them, but it's not completely sure. So if you are kind of really concerned about this, then probably the best approach to go into a self-hosted model and download and host your own model, and then you can make sure that no one will receive that data.
Mhm.
Um, there are also a couple of other techniques on how to prevent uh, storing private information. For example, you can configure a guardrail. This is how it's called. It's kind of another filter where you can pre-filter the user's input to see if it contains some private information, and stop it from sending to the large language model.
Great. So thanks for the clarifications. There are defined, already defined options to avoid to share with the LLM if you want to avoid to share with them any personal data, either the guardrail filtering or to host this model in your, let's say, location in your premise, or if
Exactly.
you prefer to use this public service hosted by another provider, you can just you have this clause, let's say, that mentions that these data are not used for any purposes, right?
Yes, exactly.
Cool,
And I
cool,
think
nice.
it's quite important actually to mention in the terms and conditions of your application that you are developing that this data can be used for. So it's quite important to mention a couple of disclaimers.
Hmm, hmm.
Also, that your data might be used for improving the quality of our services. We actually have this in our terms and conditions, because we also want to kind of analyze the users' input and to see how well we respond to those requests. We can maybe talk about this later. And
Hmm.
also because large language models are typically unpredictable, so they might answer different things for even for the same instruction. So if, for example, today I ask the same thing about the island of Milos in Greece, it might reply slightly differently, and it's kind of unpredictable. And that also worth mentioning in the terms and conditions, that we cannot control exactly what it will reply.
But this is also the case with a real person agent, right? They
Exactly,
do not have every day the same reaction, the same mood, right? It's also the case in real life.
exactly, yes. Mhm.
But great to mention that. it needs these legal, let's say, clause to be very careful on the way they are written and clarified, right?
Exactly. Yeah.
Mhm.
Okay. My next topic is about prompt engineering, and I'd like to talk to you on how we instruct our LLM to behave in a certain way. And if you are not familiar with this, we call a prompt any text that is sent to a large language model. So when you, for example, open ChatGPT and ask something or type in something, that's a prompt, that's an instruction to the LLM to generate a text. And uh, there is also a thing called system prompt, which is kind of an initial instruction that we can send to the LLM in advance, where we can teach it how to behave. We could tell it that it should behave like it should answer in a style of a 5-year-old child, for example. But we can also tell it that you are a travel agent and your goal is to help customers in finding their best vacation spots. And we can also specify a couple of guidelines on how to behave, what kind of information to collect. So I just typed here a kind of an example for that. For example, in order to book a destination, book a hotel, we will need to know the destination, we will need to know the dates, the number of people, and if we give these instructions to the LLM, then the LLM will be able to ask these questions if they were not already answered. So this is, for example, how we cover the hotel booking part of our application. Of course, the real prompt that we use is much more complex than that, but this is kind of a good example. Um, and during a discussion, we have different topics. I mean, we can talk about hotel booking, but the end user could also start to talk about renting a car or going into a cruise trip. And each of these kind of use cases require different steps. Like if I want to rent a car, I'm not interested in the number of people because we are talking about a car and not a hotel. So therefore, we can have different prompts for different use cases. And in our application, we actually have a lot of prompts, and we kind of orchestrate them to work in a nice way. So in this image, the dark blue boxes are the different chat prompts that we use. We use one for hotel booking, but we have another one for car booking, for flight booking, and in each step of the conversation, we kind of decide which one to use. And for that, we also use a prompt, a large language prompt, which is not visible to the end user. It happens in the background. We ask the LLM to tell us what is the current topic of the end user. If he talks about a destination, then we will use our main flow. If it talks about renting a car, then we will use a different prompt.
So here, Attila, let's assume that, I don't know, we need to build a different scenario for booking a vacations package in exotic locations like Maldives or something else. I guess here it could be another dark blue box with a well-defined prompt, right?
Absolutely, yes. So then we would need to think about what are the questions to ask, and we want to book a complete package. We would write a prompt that handles that use case, and then we would modify the intent classification prompt to be able to select that answer as well.
And you can even guide the model to act as a different personality, right? As a different agent, right? In these
Yes,
scenarios.
we could even change the tone of the customer of the model in that
Hmm.
case.
Hmm.
Mhm. And you've probably seen that we extracted some information from the LLM response. Like, for example, if it recommended 5 different Greek islands, we displayed them as selection possibilities. So for that, we are also using a prompt. We call it response comprehension, which takes the LLM response and it extracts the relevant information from it in a structured way. So this slide kind of explains that. We want to extract this knowledge in a structured way. So we can tell the LLM to summarize the conversation that we just had in a very strict format and answer three questions. What is the question that the LLM currently asks from the user? What are the destinations that it recommends, if any? And for example, what activities the end user was interested in. And in this case, we can get back a very well-structured response that our application can process. And for example, if the application sees that these five destinations were mentioned in the LLM response, then we can just display them as potential answers. Okay. This next slide is about how to integrate with how to integrate external tools with the LLM. And here the main challenge is that the LLMs are quite knowledgeable and they know a lot of things. They can even recommend hotels. So if I go to ChatGPT and ask it to recommend me, let's say, a hotel which is close to the Eiffel Tower in Paris, then it will be able to recommend a couple of hotels from the public knowledge of the LLM. And it might even tell me that I can go to the web page of that hotel and book a hotel for myself, or it could recommend some well-known booking sites like booking.com or Airbnb. But of course, if we are developing this application, we want to avoid it to recommend competitor websites. We want it to recommend, to use our own services. So we had to take over kind of this responsibility from the LLM. And in our main system prompt, we actually instructed it that it should never recommend hotels from its own knowledge. Instead, it should use our own tool. Now, the LLM, of course, will not be able to call a tool that we own, but we can instruct it to generate some kind of text that we can recognize in their response, and we can react to it. So we can describe it, for example, to generate a special text that we can identify. And in our case, we generated text which is displayed on the screen like /hotel search. And then we have the GPS coordinates of the destination, the name of the city. So this is an example for New York City hotel search. And we extract also the number of guests and check-in and check-out dates from the LLM response. And what our application does is when it sees that this kind of special syntax appears in the LLM response, it will take it over. We will not show this text to the end user. Instead, we will call our own hotel search API, and we'll render the hotel cards as a reaction to that. So this is how we take over hotel search. This is a common technique in generative AI. It's called tool usage.
So with the two previous slides, Attila, you explained very well my previous question also how the GenAI answers very well structured in a very, very specific way. But also here how you can limit somehow the answers of the LLM and guide the LLM to take specific actions. For example, also I guess you can have specific cars agencies to suggest for booking a car, or you can also guide the LLM to avoid suggesting specific locations to be visited in case they are forbidden or anything else, right?
Exactly. Yeah. So actually, fine-tuning an application is a lot of work. So initially, of course, you have some ideas and you will develop your application and your prompt to behave as you want, but it requires a lot of testing to see how the application will actually behave in the real world. And if you see such kind of edge cases that you want to avoid, then you will always need to go back and change your system prompt and add additional constraints and additional instructions to cover those.
Mm-hmm, mm-hmm.
Okay. A couple of other interesting ideas related to the image search functionality that we implemented. So you remember that we, on the right-hand side, we always tried to display matching images to the conversation.
Yes.
And we had kind of two challenges here. One of them is a contextual search. So if you want to implement it correctly, we cannot rely on a simple keyword search because we want it to make generic. If, for example, the user searches for, let's say, Milos, then we might want to display other images from Greece, which are relevant to the search. Or if the user is searching for a hiking trip, then maybe we want to show images which are about mountains that are kind of related to hiking. So this is one of the challenge on how to implement a contextual search that understands the specifics of the context. And the other thing was how to, so we got a lot of images. We had several thousand images in our repository, and we had to kind of label them and know the exact location. So when the user is looking for a destination, we will be able to label the image correctly. And the images that we receive from these public repositories are usually pretty well tagged. So we probably know that an image can contain some metadata inside. In the JPEG file, there is a possibility to add some metadata, keywords, headline, region. But the challenge was that different images had different approach on how they were tagged. For example, in this table, I took two images, and the first one is about a church in Vienna. The second one is about a parliament in Budapest, Hungary. And as you see, they were tagged, but not consistently. Vienna appears in the headline, but the city Budapest appears in the city tag, so it's kind of a mess. We cannot say that we will display the headline because it can contain something else. So we had the idea to use LLM to consolidate this information as well. And what we did is we extracted all this metadata from every image, and we wrote a special prompt during ingestion time. So this has been done in the beginning once for every image, where we pass all this metadata to the large language model and asked it to return us to kind of consolidate this information and understand where this image was taken from and what its general activity it suggests. And then it returned, again, a quite well-structured response by extracting the location and extracting the activity that it suggests. And the LLM is also quite good in converting locations to GPS coordinates. So this is also something that was a good experience with them. So this is what we did, and we basically took this information and we placed it in a vector database, which is able to provide this kind of contextual search. I think we don't have enough time to go into details about vector databases, but the main idea is that they are good for this kind of contextual searches, and they will be able to return, for example, mountains if you are searching for hiking, or they will understand the context of your question and will be able to answer with synonyms as well. And this is kind of the high-level architecture of our application. And if I'm talking about the images, then I will start from the right-hand side. So we had this image store, which is depicted as a database. This contains currently several thousand images, but we kind of expand on this image store every week or every month. So we keep adding new and new images. And we have a dark blue box here for data ingestion. This is basically a piece of software that processes every new image and runs this LLM that I just explained to extract the relevant information from every image. And we put the data into a vector database so that the application will be able to find the relevant images. And then if we start looking at this diagram from the left-hand side, we see that uh, the end user will interact with the web application. So this is how our chatbot is implemented. But the web application is a very narrow layer. It's just the front end, which covers kind of the user interface of the application. And for all relevant activities, all the business logic is implemented in a backend service. That's a different component of our application. And this will do the lion's part of the work. It will talk to the vector database to retrieve matching images. It will call the end user's API to identify the user and to know its email address and name so that it can send, for example, information to the end user. It will also call the customer's hotels API. And it will also call to the GenAI framework that is hosted on the AWS to guide the conversation.
Mhm. Mhm.
Any questions related to this? Okay, thank you very much. I think this was kind of my last slide, so I think we are open for a Q&A session now.
Attila, Constantina, thank you very much for this interesting presentation. I equally enjoyed the demo part and the high-level technical explanation as well. Let's see if we have some questions from our audience. We have like less than 10 minutes remaining. Let's try to answer if any questions are there and stay in time.
Okay.
Okay.
I think we have one. Attila, the question, it's a great question. It's regarding bias. So the question says, how do you manage biased answers of the tool? One example of bias in the GenAI may be that, yeah, the LLM has developed a negative view about a particular destination because, I don't know, of economic issues with this destination. Is there a way that you manage bias at the moment?
I see. Yeah, that's a good question, actually. Currently, we have some plans to manage this, but we didn't implement it so far. One of the examples I can think of is that, uh, as you also mentioned, some countries might face some unsafety reasons. For example, a public war appears in a country, and then we don't want our end users to plan a vacation there. So usually the LLMs are already quite knowledgeable of which countries are safe and which not. But of course, this can change at any time. And every large language model has a cutoff date on when its training was finished. So the model that we are using was finished a few months ago. So if something happens since then of course the large language model will not be able to take that into consideration. So we are planning to extend our application with an API call where every day we will query the safe. So the American government actually maintains a list of countries which are safe for traveling and which are not, and they make this list available through an API call. So we plan to implement this feature, and every day we will request this information, and it will feed it into our system prompt so that it can take into consideration.
So a good way to do it is to predict these biases beforehand and try to implement a specific approach to handle them, right?
Exactly, yeah. On the other hand, the LLMs, I mean, the providers of the large language models do usually a pretty good job in already taking this into consideration. So we didn't actually see big problems. They usually were able to handle this out of the box. So if we planned, for example, a trip to North Korea or to one of the conflicting regions, it was suggesting that we shouldn't go there at the moment. But yeah, it's always good to fine tune this. And on the other hand, if, for example, if you have a destination which is not well known, which, for example, a new touristic destination for which there is not enough information in the internet, then of course the large language model will not be able to answer that. So if you want to promote such destinations, then again, you need to kind of maintain a vector database with the destinations that you want to promote. And then you can always search it and provide it as an additional context to the LLM that use this list of locations as well when you are recommending destinations.
So yeah, certain ways to customize it also, but you need to consider also the maintenance efforts there, right?
Exactly.
Attila, thank you very much for this. We are running a bit out of time, but we have several questions I see, so let's please try to tackle one more.
Okay. How long it took to go live in production with this solution? Also a good question, I think.
Okay, yeah. Yeah, so it took about 6 months to develop the application, and initially we launched it as an internal tool. So as I mentioned, this customer for which we developed it is a large customer, so they had several thousand internal users. So we initially did an internal release to these employees. And after 1 month, we released it to the public. So now the application is public. So I would say that it took 7 months to go into production. It was quite quick to implement MVP, a minimum viable product. So after a few weeks, we already had a solution that was pretty similar to what you saw today, but we needed many additional months to fine-tune the application and to handle all these edge cases that we discussed and to integrate with additional data sources.
Also, I guess a big round of testing, monitoring, right? This
Exactly.
behavior.
Yeah. Yes, we also need to plan for a large number of customers starting to use the application in the same time. So we had to take into consideration scalability as well.
Great.
Excellent. Thank you very much for these answers, Attila and Konstantina. Thank you very much for presenting this very interesting topic. And moving on to our next slide, I would like to sincerely thank the audience for attending another one of the Data Zen Greece GenAI from Idea to Reality events. And again, I would like to urge any of you that would like to be part of this community to register and contact the team in order to connect at any level and produce interesting events, exchange ideas within the GenAI or general data analytics community. We will be joining with the next Data Zen Greece event after summer. So I'd like to wish everyone to have a pleasant summertime, to get plenty of rest, and see you all again after summer vacation. Thank you, everyone, for joining. Take care.
Thank you. Thank you, Attila.
Thank you.
Thanks, everyone.
Bye.